Hello everyone, Jai to all. In this video recording, I am going to discuss about the push-down automata. In this video, we only discuss about the introduction part of the push-down automata. What is mean by push-down automata? Why it is called a push-down automata? Or what is the basic concepts of push-down automata? We have discussed here. This is the outline. That means this is the topic which is discussed here. The first one is PDA. Second one is operation on PDA, third one is the representation of PDA, and fourth one is acceptance of PDA. This is the definition of push-down automata. First, we want to discuss what is mean by push-down automata. A push-down automata is a finite state machine that is implemented with memory device that called push-down store, PDS. In this, we have to use finite state machine. Finite state machine means the number of state must be finite. That means number of state must be countable, and that machine is called a finite state machine. In previous video, that is the case of finite automata. We also discussed what is the mean of finite automata. If we have to take number of state is finite, then the machine is called finite state machine. And in this automata, in this machine, we have also take the number of state to be finite, so that we called finite state automata. And why we have to use finite state automata, and why we have to use push-down automata? We have number of automata, number of machine, finite state machine, infinite machine, deterministic finite automata, non-deterministic finite automata. Besides this, we have to use push-down automata because some set of language which is not accepted by finite automata or deterministic finite automata, that language is accepted by push-down automata. There is a class of language. There are 4 types of language, that is type 0, type 1, type 2 and type 3. Here, this machine is accept type 1 language. Here, this machine is process a context-free language. This automata contains mainly 6 points. The first one is read-only input tape. Read-only input tape is a type of memory where we have to write the input data, and input data write on the tape, and this tape is divided into equal size of block that is called cell, and each cell contain a single symbol. This like this. This is the memory. We have to divide equal size of block, and each block contain a single symbol. This is called read-only input tape. Next one is input alphabet. This is a sigma. This is denoted by sigma. That means set of input alphabet. Next one is finite state control. That is the transition control. How the machine is controlled is the part of finite state control. And next point, fourth is set of final state. That is called F, where we have to finish the machine, or where we have to declare the machine is accepted the given language, is decided by finite set of final state. And next one is an initial state. This is the single state which decide from where my machine is start, or from where we have to start processing is called initial state. And the last one is PDS, push down store. This is a temporary memory where we have to store the data, or this is a temporary memory where we have to perform processing. Like if you have the string a plus b, then this mathematical expression evaluated inside the push down store. Whenever needed, we have to push the data inside the stack, or whenever needed, we have to pop the data from the given stack. This is the diagram which show the push down store, which shown in the theoretical part. This is called input tape. This is input tape, and the input tape is divided into equal size of block called cell, and each cell contain a single symbol. This is the finite state control. This is the finite state control, and this having a pointer which point the input tape. This is the PDS where we have to store Z0, Z01, Z02, Z03 and Zn. This is the direction of storing. If we want push the data inside the stack, we have push Z0 above Z1, above Z2, above Z3 like this. And if we want to remove the data, first we have to remove Z, then Z3, Z2, Z1 like this. That means this is the direction of storing and this is the direction of removing. By using this procedure, we have to perform number of operations inside the push down state. The whole model is called a PDA. This is the block diagram of a push down store where we have to perform different types of operation or different types of data. This is the definition of PDA. First, we have to discuss what is the need of PDA and what is the block diagram of PDA. Now we have to discuss what is mean by or what is the definition of PDA. A PDA is a 7 tuple. This is the main point. A PDA is the 7 tuple Q, sigma, delta, Q, sigma, tau, delta, Q naught, Z naught and F. Q is the set of internal state which is discussed in finite automata also. Always Q is the set of internal states. Sigma is the set of input alphabet. Tau is a finite non-empty set of push down symbol denoted by tau. That means if the push down store contain Z0AB, then tau contain Z0AB. That means a finite memory set of push down symbol that the symbol inside the PDS is the part of tau. Next one is delta. Delta is the transition function. What is the present state? What is the next state? What input will be taken and how we have to move from present state to next state, that is decided by delta. Next one is Q naught. Q naught is the initial state that decide from which state we have to start processing. That is decided by Q naught. Now, the next one is Z naught. Z naught is the initial symbol on the push down store. This decide from which symbol we have to push in the bottom of stack, that is the Z naught. F is the final states where we have to check our machine is halt or not. If our machine is halt on F, then we should tell the machine is accepted the given language, otherwise rejected. This is a important function which is discussed, that is called transition function. Transition function contains delta, and in PDA the transition function representation is something different from in case of finite automata. In finite automata we have to only write delta, present state, input, then next state, but here we have to write delta, that is Qi initial state, symbol to be read from tape, and that is the top symbol of stack. Present state, input alphabet, yeah, input symbol, and this is the top of the stack. By taking 3 pointers, present state, input, top of the stack, we have to decide where we have to move for next state. This is called Qj is a next state, and Ct is called top of the stack after processing. That means before processing the top of the stack is B, and after processing the top of the stack is CD. That means C comes on D. That is the main transition function which is used to process the given concepts. This is the operations on stacks which we discuss here. The first operation is push operation. This operation is similar as the operation used in data structure. In data structure, we have to use stack for push or pop operation processing. Here we also use push and pop operation, and third operation is no operation. The same operation is used here, but method of writing is little bit different. In case of data structure, we have to use function to push the data inside the stack, but here we have to use transition function to push the data inside the stack. Look at this. This is the delta. Then state Q naught, input A, top of the stack B. After processing this, we have to write Q1 comma AB. That means we have to push A inside the stack. And the operation like this. The initial condition, this is the B. After processing, we have to put A on the top of the B. And this, when here multiple symbol is come, that is called push operation. Next one is pop operation. In case of pop operation, similar movement is considered. Delta Q naught is the initial state, A is the input symbol, B is the top of the stack. After processing, we have to move next state on Q1, and the symbol to be popped that is null. That means we have to pop the top symbol B. If this is the top symbol, if this is the top symbol B, then we have to move, erase this symbol, we have to make null. According to this, the top symbol is B. After processing, we have make here null. That means we have to erase this symbol. This operation is called pop operation. And third operation is no operation. In case of no operation, the third case is no operation. In case of no operation, we have to write delta, state Q naught, input A, top of the stack B. We have to write state Q1 and here B. That means we have no change in content of stack. The before the processing, the top of the stack is B. After the processing, the top of the stack is also B. In this case, we don't have to change the content of the stack. We move one state to another state, but we can't change the value of a stack. That condition is called no operation. That this is the three operation of stack which is discussed here. The first operation is push operation, second operation is pop operation, and third operation is no operation. Push operation, we have to push here double symbols. Pop operation, we have to write here null. And third one is no operation, we have to no change in the content of stack. Now, the next type is how we have to declare or announce the language is accepted or PDA is accepted the given automata. Before this, we have to discuss the type of PDA. PDA are two types. The first one is DPDA, deterministic PDA, and second one is non-deterministic PDA, NPDA. How we have to decide which one is the PDA or DPDA and which one is the question of NPDA? If the middle terms is identified, let us discuss with example A power n, B power n. If we say that whenever writing like this A triple B, this is the midpoint, because when A is exhaust, the symbol B is started. That point we declare that the number of A is equal to number of B, and that point is a midpoint. This is the case of deterministic PDA. That means if the middle term is identified, then we can say the given PDA is the deterministic PDA. If the middle term is not identified, then we can say the given PDA is deep NPDA, like this, W power R. In this language, we can't identify the middle term, so that this PDA is called non-deterministic PDA. Now, the next one is representation of PDA. How PDA represented inside a memory is discussed here. There are three types. The first one is instantaneous description, that is called IDs. Second one is transition diagram, and third one is transition table. But here mainly we have to use two representation. We can also use instantaneous description, but mainly here we have to use transition diagram and transition table. In the designing part, for easy to understand, first we have to design diagram for a given PDA. After that we have to write down the transition function or transition table or instantaneous description. But to understand easily, we have to first draw diagram for a given language to design a PDA, which is discussed in next video. Here we want to discuss what is meant by instantaneous description. Instantaneous description means like this. We have to write delta, state Q naught, input A, top of the state B. We have to write here next state Q1, input A, and top of the stack Z, like this. If we want to write here this transition function in a instantaneous description, we have to write like this. Q naught, A, B, like this, then state Q1, A, Z. This is called instantaneous description, and this is the main funda up to represent the PDA. Next one is transition diagram. What is mean by transition diagram? This is a transition function, and we want to draw a diagram. That diagram is called a transition diagram, like this. A state is Q naught. We have to mark his Q naught as a initial state. Next state is Q1. Here we have to mark a next state Q1. We draw a directional edge Q naught to Q1 and mark here input A, top of the stack B, and operation to be performed right here Z. That means we have to convert B into Z, so that we here slash we have to write here Z. If no operation, if the case of no operation or if the case of delete operation or pop operation, we have to write here slash A comma B slash null. Transition table is inefficient here. We have not discussed about the transition function in case of PDA because that is an irrelevant question. So that we have to use only two types of representation: instantaneous description and transition diagram. The next one is how many times the machine is accepted the given language. The first one is through final state, and second one is through empty stack. Before going to this topic, we want to discuss what is mean by acceptance of a string. A language L can be accepted by a PDA if in two ways. There are two methods to declare a language is accepted by the given PDA or not. The first one is by through final state. After processing the whole string, we reached on final state and string is exhausted, then we have say the string to be accepted. And next one is through empty stack. Processing the whole string, we reach on final state or which may be the final state, then string is said to be non-final state or string to be not accepted. This all about the PDA introduction part. If any doubt, you can message or comment in comment box.